Yeah, hi. So for those who were here for the Google Big Table talk, this is actually a really good extension of it. We're going to cover some of the same territory. So maybe with a slightly different spin, but hopefully it'll be sort of reinforce some notions. Yeah, so first, I'm Justin Coffey. I work at Criteo. I'm in the SRE team there. I've been there for about going on 8 years now. And I've seen quite a lot of growth at Criteo. I'll talk a little bit about our scale just to give you guys some context around this talk. Yeah, so let's go ahead and get going. So on the agenda side of things, we're going to talk, this is a little bit of storytelling for the Americans in the crowd. I'm a big fan of NPR and so This American Life, so this is sort of this SRE's life a little bit. So we're going to go through introduction, context, and motivation, sort of why I'm doing this talk. The story is really about a feature team becoming a service team and trying to figure that out along the way. Obviously, figuring out things along the way meant that we had a little bit of a misdelivery, and we're going to talk about that. And then we use that as a way to reboot as well what we were doing in the team. And I'll talk again about what that reboot was, how it was different, and then I'll sort of try to tie everything together with some closing thoughts that might provide some takeaway lessons for folks. Okay. So introduction, context, and motivation. So yeah, so I've briefly introduced myself already. I've essentially done most of everything that has to do with batch data processing at Criteo in my career. I'm a manager there. I started out as an IC, went through the ranks and that sort of thing. And pretty much anything that has to do with offline data processing has my hands on it to some degree. Standard disclaimer, all the mistakes that I'm going to talk about at this conference are pretty much mine. Okay, so let's start with a little bit of some deep thinking. What do we try to do when we're software engineers? Essentially, we're trying to provide utility to someone else. Sometimes we try to provide utility to ourselves. I'll talk about that in the second deep thought. But mostly, we're trying to provide utility for other people. A reasonable example is a Linux kernel providing scheduling and driver interfaces to OS vendors who can use that to build a platform that allows other developers to do stuff like write compilers, web servers, and whatnot. They give that all off to web developers who are going to build applications. And of course, the stereotypical application these days is looking at cats. So that obviously provides utility to a large group of people because I think it's like the second or third most popular thing people do on the internet. So the first, I'll let you guys think about that. Okay, so deep thought number 2. Not all software is destined for massive utility. This is what I alluded to just a second ago. Sometimes we write things for ourselves, and actually this was talked about by the Big Table guys as well. We write scripts because that automates some portion of our life and so it provides utility for us, but not massive utility for others. Occasionally, we start thinking that even maybe in a small group of people, we want to do something better than scripting, and so I'll write some shared libraries, and we'll sort of test those and share them and build a little mini system. When we do this, we're taking lots of shortcuts, right? We're not thinking about a general system that we're going to deploy to the world. We're thinking about our little hyper-local environment. And so we can bake in tons of assumptions. And so, going from the scripting thing to something that's, a big service like Bigtable and what I'm going to talk about, it's not a straight line, basically. Okay, so Criteo, who are we? The joke is that you may not know us, but we know who you are. We sort of pioneered personalized recommendation in banner ads, also known as retargeting. And so what that means is we have trackers all over the internet. We're part of the third-party tracking folks. Disclaimer, we do not keep demographic information at all. We're also headquartered in France, which has some of the strictest privacy controls on the planet. And so your data is safe with us. It's anonymized and all that good stuff. But nevertheless, we observe a large portion of the internet. We track, I've got 1+ billion users a month here. Last time I looked, it was like maybe closer to 2 billion. It's a lot of people. Inside R&D, So potential clients for a data production platform is about 1,000. That's when you take all of R&D engineers who might need to produce a feature, as well as analysts and even some product management folks and whatnot. To give you an idea of rough numbers, we frequently cite that we deal with about 500 billion HTTP events per day. And so that gives you an idea of the scale. So yeah, TLDR, we're not small. That's not the Docker whale, that's just another whale. I figured a blue whale is a good metaphor for big. All right, motivation. So this is something that's been brewing in my head for a long time. I've been doing this same job in different forms for about 7, going on 8 years now. And I've worked with amazing engineers in my team, as fellow ICs, fellow engineering managers and other ICs and other groups. Criteo is just filled with amazing engineers. But we've done a lot of stupid things, right? And so how does that happen? So that's a lot of what this is about, and I thought I could share that, and maybe some other folks could get some value out of it. Also, Criteo is a really big and diverse organization, especially in R&D, and we encourage open and honest debate. I don't think everybody at Criteo is going to agree with what I have to say here today, and so this is my perspective, and you should understand that. Okay. So let's start the real storytelling portion. Feature team becomes a service team. So the early years. So we just started out, we were just a few people, some engineers and an analyst, and basically we had all these tools at Criteo, what we called tools, which were little ETL programs written in C#, sort of hand deployed, and these big sort of multi-threaded at some point, but basically single process tools that were trying to process all the incoming data and build little data cubes and data marts and whatnot. And at some point, under the onslaught of data that Criteo started having, this just all started breaking. And so we needed to fix these things one by one, and we did that. It turns out that actually taking a single transformation and implementing that with the tools that were given to us at the time, which was primarily Hadoop and Hive, was pretty straightforward. The one thing that we didn't have, though, that was obvious to use was some sort of orchestrator. So, we're going to have this big graph of jobs, that the jobs themselves are easy to write and test, but to actually get them into production and then ensure that they're executing in the proper order turned out to be a lot more challenging than we had initially thought. We're sort of Unix folks, and so we, of course, were dealing with our own production, and so we scripted our way out of the problem. It worked really well, and we were happy, and we sort of consider these the wonder years. This was, was better back then kind of thing. So everybody basically agreed that this was a good system. We got lots of congratulations from other folks in the R&D organization because we solved this big problem. Okay, so we're popular, and so we start getting requests for help, lots of them. So we got all these people showing up, basically people started asking if we could help them get their data features into production. There were lots of other data features happening outside of replacing all this legacy stuff, and we had sort of made some noise, and so like, hey, can you help us? And so of course, like we were totally, in total vanity. We're like, yeah, of course we can help you. It'd be awesome. We'd be so happy to write your MapReduce jobs and put them into production. And by the way, if you have a MapReduce job or a Hive query you want to put in production, just push it into our repo, no problem. By the way, still don't know who the guy is on the end. But he's there. So it's sort of to put a finer point on is that we weren't really sure exactly who all these people were who were coming in and asking for help. All right, so surprise, right? We're victims of our own success. This works so fabulously well that it breaks, right? One of my favorite people in this space, a guy by the name of Josh Baer, an TPM at Spotify, he coined the phrase, I think he coined the phrase, at least he's the one who told it to me, we are doomed to succeed, and that's certainly what happened in this case. So what are the problems, right? Well, obviously we built a script and we had a mono repo and there's like no user isolation, there's no multi-tenancy controls or anything. So, noisy neighbors, broken jobs without owners, all this stuff happens. And sort of in the first inkling that we might be an SRE team is we're operating the code of other people, right? Where people have pushed code into our repo, we put it out into production, and things start breaking. But we weren't prepared for that, right? We didn't really understand what we were getting into. We were sort of this young, naive team who was building stuff, and it was working until it stopped. So the tooling that we also had at this point, again, going back to the scripts, was basically we were deploying this little Ruby scheduler out into a Bastion host, an edge host, an edge node in our Hadoop cluster, and sort of firing things up and running. It used GDB state database, for those who know what that is. Very trivial sort of code. Our monitoring consisted of log files, and so we would go in and grep every morning to see what was happening and things like that. And so it was obvious, even though there was a big broad swath of code that was out there that wasn't ours, we couldn't actually even ask our ostensible clients to go monitor their own things, because you can't honestly go ask somebody to log into your Bastion host and spawn a tail or something like that. So we were undertooled, and things were breaking. So at the same time, a really critical system at Criteo started to break. This was our billing data pipeline. Obviously, just the name, certainly to us at that time, inspired fear. It's actually called the maintenance, but in any case, a better descriptive is the billing data pipeline, and it's failing. And we won the no bid contract. Like they said, you're going to do it. Okay, we'll do it. So we now have new requirements. So SLOs exist, right? We have hourly production. We were previously doing daily production. Batches need to be available 20 minutes after the close of an hour. We were sort of happy if things got done by noon. There was SOX compliance because we were going public, so all this stuff needed to be audited and have tight controls. And obviously it needed to be correct. And what does correct mean with data? Well, that's actually kind of a complicated topic. You have to dig into, how many messages can we drop, and sort of audit the whole chain. And so this was complicated. And of course, we still had all the old problems that I just talked about, right? We were completely undertooled even for this, easy daily batch stuff. So we needed to rethink. Okay, so new problems, new system, right? So the scripts don't cut it anymore. And okay, that's pretty good. Okay, good. Can everybody sort of see the code? Okay, great. So our analysis is that basically we need some sort of real scheduler, right? We weren't thinking in terms of service at this point, because in our analysis, the service was going to be too complicated. We realized that we had a multi-tenancy problem. But we also realized that we had a deployment problem. So in our analysis, doing a scheduler as a service meant having some long-running process out there to which we can deploy things to, right, that will accept new work. And that meant all kinds of change management, like what does it mean to break a data production graph? What about schema evolution? What about just changing the artifacts that are running? And then how do we ensure fair scheduling amongst all these different processes that are running, right? That's writing a real scheduler, like a Linux type scheduler, right? And so we're like, this is way too hard. We're using Hadoop. Hadoop has Yarn. It does all this multi-tenancy stuff for us. We can just punt on those questions, and we can build an embedded scheduler. And this little embedded scheduler, people can pull into their projects and then go deploy that off. And this will solve our ownership problem, because it'll be clear that it's their jobs in production using our scheduler to operate it. And it can be efficient because we can have this nice multi-threaded process that allows people to orchestrate things efficiently. And so we did that. And we wrote it in Scala. I've got a link to the open source version of this code. This is actually the second scheduler that we wrote in Scala, which is a whole different discussion. But I won't have time. I would love to go into it, but I won't have time to fully go into that one. And yeah, so a quick walk through the code here. Does this work? Okay, good. So if we look here, we see basically we've got a Scala object. So this is the Cuttle code here. So we've got our Cuttle platforms and time series scheduling and whatnot. We don't really need to worry too much about what time series means. But basically, we pull in the scheduler SDK here. We define a sort of an epoch for this scheduler, which in this trivial example is yesterday. Generally, you want that to be a static day. But in this case, we're just doing yesterday. And then we're just going to do hello world. So we define a job that's hello. All it's doing is it's taking our little context, which provides a start time, and saying hello, printing that out to our info stream, and then we're doing world here, doing the exact same thing. And you can see that this has an hourly period, or you can infer that this has an hourly period. And then once we've got these two jobs, we can bind them together with a little operator here that we call depends on and say world depends on hello. So we'll get those executed hello and then world. And then the project will start. So it seems pretty easy, right? Oh, and then of course, basically, these are, for those who don't know Scala, this is a Scala closure. So you can sort of do whatever you want between here and here, right? And we'll get back to doing whatever you want because that's part of the problem. However, oh yeah, so let me talk a tiny bit about why we chose Scala. So in this day and age, there's Apache Airflow. It's in Python. Data processing is apparently turned into Python, or Python was turned into data processing. But that didn't really exist, or at least didn't have the same momentum. The 5 or 6 some odd years ago when we were conceiving the initial version of this scheduler. Back then, it was all about Spark. Twitter had a project called Scaldane. And these native APIs the native APIs for these things were in Scala. And we had to reduce cognitive load on us when we were going to go ahead and build our billing data pipeline. We said, well, we're going to write some jobs in Scala. We'd like our orchestrator to be in Scala because then we can have one big, nice, happy IntelliJ project. And we can really understand and manipulate exactly the semantics of the scheduling that we want. So we felt we had good control over what we were going to do. And we were reducing cognitive load. Obviously, we could define the jobs in one project and then go spin off like some sort of other scheduler and some other code and sort of stitch things together. But we felt that that was going to introduce errors. So we did that. So let's jump into the misdelivery and analysis. I should quickly say that, and I'll touch here. It worked. It really did work, and it does work. I'll talk a little bit more about the extent to which it works. This embedded SDK works quite well. For the billing data problem in particular, it was a revelation in terms of its performance characteristics and reliability with respect to what we were doing before. It was white-boxed monitoring. It was multi-threaded. It had its own interface for monitoring and orchestration, runtime manipulation of what's going on. Had really good catch-up properties. So if Hadoop data was late for some reason, our ability to catch up was quite good because it was parallelized and all kinds of good properties. And also it just worked, right? So our gamble about bugs in terms of the jobs and workflows we were putting into production appeared to have paid off. So we were really happy. We were like, slapping each other on the back. This is great. This is wonderful, right? And so we said, hey, this is generally available. You guys should all move to it. It's going to be great. And by the way, we're going to push this down your throats because we need to get rid of that old graph of data production that we had before. But even for new work, right? Forget about legacy, finding owners and stuff like that, and all the pain that entails. Even for brand new work, people were really reticent to use our scheduler. And we're like, we don't understand. So we eventually started talking to our clients. So this goes back to the big table talk about talking to your stakeholders. We dog-fooded the snot out of this problem. We were super happy, but we hadn't engaged our clients prior to that. And so we started finding some things out. What's an idempotent job? Why at least once scheduling? Scala is hard. I only have one job to run. I don't need a whole thing. Can you just do it for me, right? And then the random guy who really just seems to be like completely confused. So this is what we were confronted with. And when we took a step back and started thinking about it, our first analysis was, well, hey, wait a second. People actually don't understand the domain that we're experts in. This is an educational problem. We've spent quite a long time, going all the way down to the bottom of this particular rabbit hole and came out experts, and we learned a whole bunch of core principles, and then it was surprising to us that people who hadn't done that didn't know these same principles, at least with respect to data production. So we shouldn't have been surprised, is the moral of that story, but we were. Also, we were surprised that Scala was deemed more complicated to pick up by other teams than we thought. The context at Criteo is that most of what we call the top-level applications, so the folks who are building these big internet-facing services that deal with those 500 billion events per day, that's all in C# and on the CLR. We were in the batch processing Hadoop world, which meant the JVM, so we went with Scala, and the CLR guys are like, yeah, that's hard, we don't understand it, we don't want to deal with it, and so this is sort of a problem. So we realized that not only could we not foist all those old jobs off onto our data producers, or ostensible data producers, but even new data production was going to be difficult to get onto our scheduler. And so this established a hybrid world where we have sort of cheap, easy data production for trivial use cases, and then the serious stuff requires serious investment from development teams. And we accompanied them on that, right? We really did go out on an educational campaign. We do Scala trainings, we do data engineering trainings, and the whole 9 yards. And so that actually really did work. We do have about, I think, 200 of these embedded schedulers out in production today. They're responsible for generating, over the years, exabytes of data. It really works. So, right, so we've seen this broad adoption of our scheduler, but people, even folks who have adopted it, some of them, not everybody, some people really like it, taste or whatever, I guess, or they have similar, predilections as us in code, and so it's really adapted for them, but for other folks, it's still really painful. And also, toil on us, on our team, providing this SDK is actually quite high as well. Primarily, we're spending time supporting folks. And so why is it high? Well, from this diagram here, that I just sort of, put together very quickly. It's completely incomplete and might not say a lot, but I'll go through it quickly. So basically, client code is sitting on top of our scheduler, right? And you can see that. And here I've just taken some examples of things that our scheduler executes. So, there's Hive queries. So for those who don't know Hive, it's SQL that computes out to MapReduce jobs. It's quite nice. Spark, similar, it's just not MapReduce. Scoop is a tool that allows us to interface. It's basically a command line tool that allows us to get data out of a database and sync it down to Hadoop, or do the reverse of that operation. And then also, folks can fork processes. They can spin up long-running processes in the JVM themselves. They can do whatever they want, right? So the body of code up here is actually huge inside of a scheduled system. So then we have our scheduler here, and in fact, one of the other problems that we realized as part of this whole process was that this is actually, just really a portion of the infrastructure at Criteo, and our scheduler encapsulates all that complexity, right? It tries to abstract it away. It tries to make it so that you have this nice deployment container in which you can take a bunch of things out of the SDK, like how to run a Hive query or whatnot, stitch that all together nicely, and it will just magically work in production. But what we realize is that, your Kerberos token in development environment, in pre-production expires, the process didn't renew it properly, and you get a weird exception in your code. You don't know why it's not working. So, but who are you going to talk to? You're going to talk to us first, because it's our scheduler that's running that just crashed, right? It's ours. We're the ones who wrote it, so we're the ones who provided a way to get it into production. So they talk to us for a Kerberos exception that, we're like, you need to get, a new ticket renewed. And this happens at many different layers. And what ends up happening here is that we end up debugging quite a lot of infrastructure problems through our SDK. Now, obviously, sometimes they're too hard for us, and so we have to hand clients off to other teams in SRE. So then they go and get handed off, and then that team has to understand the context under which, the thing broke. And so there's this friction in terms of knowledge transfer and handoff time, and meanwhile the client is waiting and trying to get their thing resolved. And then sometimes we go through these handoffs and we go through back and forth, and in fact the problem was in client code, and nobody realized it until we digged even further into the problem. once we got to sort of the end of a particular branch of analysis. And we bubble back up and look, oh, actually, you're closing over something that you shouldn't, and that's what's causing the exception. Or you have some sort of like hidden class path problem or whatever that only shows up at runtime. There's a million different reasons why it breaks, and so it all goes through this scheduler SDK, which is considered to be the container. And so what this really means is that this is sort of starting getting to this idea that we were too ambitious in what we were trying to abstract away in just an SDK. And we started seeing how this SDK has now like grown quite a bit and is approaching what could be considered to be a service, even though it's just an embedded library. So there's one other thing that happened. So MySQL, MariaDB. For reasons that I'll explain in a second, we decided to change from a MySQL deployment using Galera for multi-master state storage. The scheduler has to keep state, so it needs to checkpoint what's happened in its data production graph. So in the world depends on hello, it needs to remember that world has executed before it can execute hello, and that needs to survive restarts. And so it needs to have that execution state stored somewhere. And so we've chosen MySQL. But we chose MySQL before we had official MySQL infrastructure. Then we got official MySQL infrastructure in the form of MariaDB. So let's talk about that. It took us 6 months to do this migration from MySQL to MariaDB, right? Like binary compatible, I guess. Certainly the API is. And it took nevertheless 6 months. So how could this possibly have taken 6 months? Well, basically, release lag, right? The holy grail, I think, for everybody is continuous deployment. I don't know, show of hands, who has continuous deployment across everything at your company? Okay, congratulations to you two people. I'd like to talk to you afterwards. So we don't have continuous deployment. We have continuous delivery of artifacts. We have a monolithic build. We know everything builds, and we have artifacts that are releasable, but they're not always released. And so what does that mean? Well, if we go back to our little example, when we looked at the scheduler code, we realized you can bring in lots of different things. Well, bringing in all this different stuff might be valid at a certain point in time, but then as infrastructure starts changing or different assumptions are made about how that code is going to be executed, and you try to bring in new things, you might be breaking client code at runtime. And as it turns out, when we were doing this, we had most projects had small release lags, say a couple of weeks, and so they would get our code changes, which came from the DBA team. The DBA team added service location into their little MariaDB SDK. We didn't have that. We had this quick and dirty deployment of MySQL. And so we needed to get their SDK into ours. We needed to bump the artifact and push it out. Most of the release lag was pretty low, like I said, about a couple weeks. And even for a release lag that was longer, most of the code was good. And so it just was a simple bump and release. And I would say, 80% of projects, maybe even 90% of projects were that way. But there was the long tail. And the longest of the long tail was a team who hadn't released their code in 9 months. So they were on artifacts that had otherwise been cleaned from our Nexus. So like the code just didn't exist anymore. And they said, yeah, so we can build and we can test inside the what we call the MOAB, the monolithic build process. But every time we run, everything breaks. So we have all these runtime exceptions, and the code doesn't run. The person who built this project is gone, and so we don't know what to do. We have other things that we're working on. We're not going to be able to get to this for at least a quarter. All right. So we're like, well, that's a problem. And we had other cases that were like that, not as bad, but we had other cases like that. And we only had so many people who we could sort of deploy in the field to fix these problems for people, and so this sort of serialized out over 6 months. Which I think everybody can agree on is a huge amount of toil, completely unacceptable for just migrating from one database to another, the migration that we had otherwise automated. Okay, so let's go back and do a little midterm postmortem here. So what were our mistakes? And these are the same mistakes that the Google guys talked about, I think, or at least in some of them. So we made totally incorrect assumptions about what our clients understood about what we were experts in, right? That's a problem. We chose a language with a steep learning curve. So even though that language is a good language choice, I still maintain at the time, nevertheless, it's a very complicated language for people who have never looked at Scala code. You know, your first day of grokking Scala is hard, right? And even your first months of grokking hard Scala is really hard. And then the third thing, and is more fundamental and to this talk, is that our SDK approach blurred the lines of responsibility between who is doing what. So infrastructure changes, who needs to do what. This is just code you're bringing in, but we're actually so hard-coded into the infrastructure. We're taking so many assumptions about the infrastructure in our SDK that now it's actually sort of our responsibility to make sure that this is a seamless thing for you. Whereas we just like to say, hey, it's your code, you deal with it, you do the deployments, you migrate your MySQL database. But that doesn't really work. Okay, so we need to reboot. And so, you know, this isn't working, part 2. Gut instinct basically has gotten us pretty far. But now we need to sort of build some sort of strategy around what we want to do. And so it actually, we didn't need to look very far. SQL, and so there's the strategery. While I was on the retro theme with the Wonder Years, I thought it was time for George W. Bush to come back. So we actually took a look at, we own Hive, we own Presto. Presto is a Hive-like thing, just faster, better, you know, fancier. And we didn't really need to look very far because SQL offers this really nice abstraction, right? Like, when was the last time anybody got a runtime exception submitting a SQL query to MySQL? Like, probably not very often. I can't remember. You know, you'll get sort of compile time errors if you know, your query is incorrect or you're, you know, referencing metadata that doesn't exist. But, you know, once the query goes to the planning stage, it just works. And so we thought that maybe this was a reasonable place to start looking about how we could create sort of a DSL that would allow us to pivot into providing a service. So what would we need to do well, first, oh, sorry, I'm ahead of myself. So nice properties of SQL and RDBMS model. So one thing about SQL is it's easy to parse, right? There's lots of SQL parsers out there. We wrote one. We wrote many, actually, for different reasons. And it's also self-describing, right? So like everything you need to know about how to execute that query from a database operator or writer is in the SQL query, right? You don't need to, there's no other assumptions about that. It's a DSL, and it runs in a sandbox, you know, the database server via RPC, right? So this is just a fancy implementation of, say, sending a post to some other service. You know, the post, the body of that post is a command, a language that's being parsed by that server in some way and executing something in this really nice safe sandbox that will sort of always work, or that's the guarantee. A database server is the same thing, just with SQL. So it's more complicated, but it gives you the same guarantees. The other thing that's really nice about SQL is it's not hard, right? Everybody knows it, at least at Criteo. Of those 1,000 people that I referenced, you know, 900 of them are somewhat proficient in SQL, and some of them are extremely proficient in SQL. So we figure that this is like a good entry point. But so how are we going to actually schedule SQL, right? So that's fine. So SQL is a self-describing unit of work, but what we really want is to stitch together multiple units of work correctly. Okay, so I'm running short on time, so I got to go quickly. So, okay, scheduling SQL. So I'm going to go a little bit quickly here because this isn't really the core part of the talk. But so here we have a SQL statement, right? Just a standard old SQL statement, selecting, you know, a day, some sort of column, and creating some sort of metric here from some other table. So we're selecting foo for every day, counting the number of foos from bar, and parameterizing that daily down here. Okay. So how can we schedule that? Well, we need to add some extra information to this. So the first thing we need to do is we need to give the thing a name, right? Because we're going to save the results of this execution. So we're going to give it a name. And then we need to figure out a domain of partitioning, right? Because every day we want to do an incremental computation, right? We don't want to rewrite the world every day. That's too expensive. So incrementally, we want to build new stuff. So what we've done here is we've created sort of this time series enumeration with a keyword daily, but this actually accepts any valid cron expression. And we're going to capture a value of daily in t. And so for each t in this time series, we're going to create a new partition here, cast it as a date. So this is a timestamp, but we're casting it as a date. So we're going to name that day. And so we've moved the day value into the partition, so it's out of the core schema. The rest of the SQL statement looks pretty similar. And what we're going to do is we're going to take that same variable that we assigned here, and we're going to bind it to the predicate of the query. And then that's it. That's the whole thing, right? Now we can schedule this thing. We have everything we need to know in a declarative format of how to schedule it. So this versus the SDK approach, so here I've done another little thing, which is I've added a second enumeration. So we've got, at Criteo, we have platforms across the world and data centers that we aggregate into platforms, but they're an important notion for us in internal partitioning. And so here I'm just showing you that we can add an arbitrary partition value here, and then we can bind that as well. And so we can add that as a partition output, and then we can also bind that into the source data set, so the parent of this data set. We don't have to bind that here, but this gives the scheduler clearer instructions about when to start, right? So we can parallelize on that. To do the same thing in the code over here, we have to sort of break out. And so by the way, if anybody's a Scala expert in here, I wrote this in PowerPoint this morning, so I hope it's right. But basically, our scheduler has no notion about this partitioning semantics here. It has zero notion. It's a black box scheduler. So what we have to do here is now we have to get into some, like, you know, depending on your opinion of Scala, some hairy Scala to wrap the production of our jobs in a for comprehension that's going to produce a subset of a graph here. So for each partition, we're going to produce a world depending on hello graph. And then we need to get that out. We need to bind that into hello worlds. And then we need to reduce that and use a second operator here of our graph and combine it with an and. And then now we have our graph. So, you know, I mean, I can write that. I'm sure a lot of people can write that. But, you know, an analyst, you really don't want an analyst writing that. You'd rather have them writing that. We can extend this model relatively in a straightforward way. This is based off of Google's F1 query paper inspired this little hack, which is where we have table-valued functions that we call foreign transformation interfaces that allow us to basically fork outside processes. And this is sort of our form of RPC. So arbitrary binaries or packages or whatever services, anything you can really describe here, we can fork. And we can also parameterize the source data with a SQL query. For exporting data, which is another thing you want to do with ETL, we can extend further with a copy extension. So we can generate this thing and just say, hey, copy that out to a different system. Okay, so how did we make this switch? We had to take a step back. We had to think, we had to talk to our users, and we had to figure out what they were really wanting. And what they really wanted was not to operate their schedulers. Nobody wanted to operate their own scheduling platform. They just wanted to give us a description of a job, maybe a complicated one, and have us execute it for them. So we went through this whole process. Yet another talk, is this agile, is this waterfall? I don't know, you decide. I don't even know anymore what's agile and what's waterfall. All I know is think before you do, and talk to your users and iterate with them. All that's quite important. So I'm totally out of time, and I'm going to skip over the planning phase, how we plan the delivery, and I'm going to go to summary findings quickly, because this just goes back to, I think this is the core takeaways. So extrapolating out of, so this is one specific domain's analysis, right? And so taking general principles out of this specific domain, you know, is treacherous territory. It's a rabbit hole that we went down and we came back up with something useful. But, so we have to be careful. But so nevertheless, let's see if we can't come up with some. So the first one is listen. Originally, when I first wrote this, I wrote communicate. But I wanted to underscore that communicating is a two-way thing. And it's easy for us to preach, so like I'm doing right now, and to forget to listen. Why do we educate people? So that we can build a common language between us and our stakeholders such that we as service providers can get a better understanding. We have a common language to discuss things and get a better understanding of what our clients really need. More particular to SDKs not being services, one hint is if your SDK requires state, it might not be an SDK, right? I mean, you're guaranteeing the persistence of a bunch of variables in code, for some duration of time. That sounds like a service. And then the other thing is don't over-aggregate. And so this goes back to the notion that we had all this complex infrastructure that we were trying to abstract away. And if you sort of think about it, in distributed systems, we talk about how we need to plan for the resiliency of an individual system, right? Because the underlying components might break. Well, we also need to think about planning for infrastructure change, right? And change can be seen as a sort of failure. If you don't build it in, if you don't accommodate it, it means failure for your clients. And so you have to think about how you can actually spare your clients from those changes. And the more you aggregate, the more likely you're going to have these changes to deal with, and the less likely you want to have to re-release the entire world, because that's just toil for yourself and your clients. That's it. Thank you very much. It was a little bit more verbose than I had hoped, but the peanut gallery over there knows that by now. My colleagues are over there. They know I talk a lot. So thank you. And just final note, we're hiring. So, yeah.